Hello learners, welcome to the course Statistical Methods for Economics, Continuous Uniform Distribution. In this session, we will discuss the concepts related to continuous uniform distribution, important features of continuous uniform distribution, practical solution to the problems of continuous uniform distribution, application of continuous uniform distribution in real scenarios. In the previous module, we have discussed one of the important discrete theoretical distribution, that is Poisson distribution. We have understood the probability mass function of the distribution, the important features associated with this data, and how to fit a Poisson distribution. Also, certain relevant problems were solved on this particular distribution, and the applications of the Poisson distribution in economics has been discussed in detail. In this session, we shall try to understand the one of the continuous theoretical distribution. Introduction. The continuous uniform distribution is a probability distribution that describes a continuous random variable where all outcomes are equally likely over a specified interval. It is often denoted as U of A, B, where A and B are the lower and upper bounds of the interval. The continuous uniform distribution is commonly used to model situations where all outcomes in an interval are equally likely, such as the arrival time of a bus or the height of a person selected at random from a certain range. It is also used in statistical inference, where it is used to generate random numbers for simulation studies. We shall look into how a continuous uniform distribution is defined using a probability function. A random variable x is said to have a continuous uniform distribution over the interval a to b if its probability density function is given by f of x is equal to 1 by b minus a in the interval a less than or equal to x less than or equal to b, 0 otherwise. Then x is a uniform variate and the distribution of x is called uniform distribution. We shall now look into some examples of continuous uniform distribution. The height of a person selected at random from a given range. The temperature in a particular region on a given day. We shall now understand the features of continuous uniform distribution. Using notation, the continuous uniform distribution is identified as x follows uniform distribution A, B. The continuous uniform distribution has two parameters A and B. For a continuous uniform distribution, the PDF is equal to f of x is equal to 1 by b minus a in the interval a less than or equal to x less than or equal to b, 0 otherwise. The continuous uniform distribution is defined over a range of values from A to B. Any value within the range has a positive probability of occurring, while any value outside this range has a probability of 0. The cumulative density function for a continuous uniform distribution is a linear function that increases uniformly over 0 to 1 over the interval a, b, and is given by 0 if x is less than a, x minus a divided by b minus a if a less than or equal to x less than b, 1 if x is greater than or equal to b. The mean of a continuous uniform distribution is a plus b by 2. The variance of a continuous uniform distribution is b minus a whole square divided by 12. The standard deviation of the continuous uniform distribution is square root b minus a whole square divided by 12. Equal probabilities. The continuous uniform distribution assigns equal probabilities to all values within the specified range. This means that the probability of a value falling within a subinterval of the range is proportional to the length of the subinterval. Symmetry. The continuous uniform distribution is symmetric about the midpoint of the interval a, b. The uniform distribution is also termed as a rectangular distribution. The continuous uniform distribution is a flat distribution, so it does not have any mode. We shall now look into how to compute the probabilities using continuous uniform distribution. A company manufactures bolts of a certain length that must be between 10 and 12 inches long to be considered acceptable. What is the probability that a randomly selected bolt will be between 10.5 and 11.5 inches long? For a given problem, define x as the length of the bolts. Then we have x follows uniform 10, 12. Now consider the PDF of continuous uniform distribution, which is f of x is equal to 1 by b minus a in the interval a less than or equal to x less than or equal to b, 0 otherwise. Considering a is equal to 10 and b is equal to 12, we have the PDF as f of x is equal to 1 by 2 in the interval 10 less than or equal to x less than or equal to 12, 0 otherwise. Now, to find the probability that a randomly selected bolt will be between 10.5 and 11.5 inches long, consider probability of 10.5 less than x less than 11.5, which is equal to integral 10.5 to 11.5, 1 by 2 into dx, which is equal to 1 by 2 into x in the limits of 10.5 to 11.5, which is equal to 1 by 2 into 11.5 minus 10.5, which is equal to 1 by 2. So, there is a 50% chance that a randomly selected bolt will lie between 10.5 and 11.5 inches long. A delivery company guarantees that packages will be delivered within 5 days of being sent. Suppose that the time it takes for a package to be delivered follows a continuous uniform distribution between 3 and 7 days. What is the probability that a package will arrive in less than 4 days? For the given problem, define x as the time taken to deliver the packages. Then we have x follows uniform 3, 7. Now consider the PDF of continuous uniform distribution, which is f of x is equal to 1 by b minus a in the interval a less than or equal to x less than or equal to b, 0 otherwise. Considering a is equal to 3 and b is equal to 7, we have the PDF as f of x is equal to 1 by 4 in the interval 3 less than or equal to x less than or equal to 7, 0 otherwise. Now, to find the probability that a package will arrive in less than 4 days, consider probability of 3 less than x less than 4, which is equal to integral 3 to 4 1 by 4 into dx, which is equal to 1 by 4 into x in the limits of 3 to 4, which is equal to 1 by 4 into 4 minus 3, which is equal to 1 by 4. So, there is a 25% that a package will arrive in less than 4 days. The temperature on a particular day is uniformly distributed between 50 and 80 degrees Fahrenheit. What is the mean temperature of the day? For a given problem, define x as the temperature on a particular day. Then we have x follows uniform 50, 80. Now consider the PDF of continuous uniform distribution, which is f of x is equal to 1 by b minus a in the interval a less than or equal to x less than or equal to b, 0 otherwise. Considering a is equal to 50 and b is equal to 80, we have the PDF as f of x is equal to 1 by 30 in the interval 50 less than or equal to x less than or equal to 80, 0 otherwise. Mean of the continuous distribution is a plus b by 2, which is equal to 50 plus 80 divided by 2, which is equal to 65. So, the average temperature for the day is 65 degrees Fahrenheit. Note that the mean of the continuous uniform distribution is simply the midpoint of the interval over the distribution is defined. In the example above, the distribution is defined over the interval 50 to 80 and the mean is located at the midpoint of this interval, which is 65. Electric trains on a certain line run every 15 minutes between midnight and 6 in the morning. What is the probability that a man entering the station at a random time during this period will have to wait at least 10 minutes? For the given problem, define x as waiting time for the customers. Then we have x follows uniform 0, 15. Now consider the PDF of continuous uniform distribution, which is f of x is equal to 1 by b minus a in the interval a less than or equal to x less than or equal to b, 0 otherwise. Considering a is equal to 0 and b is equal to 15, we have the PDF as f of x is equal to 1 by 15 in the interval 0 less than or equal to x less than or equal to 15, 0 otherwise. Now, to find the probability that a man entering the station will have to wait for at least 10 minutes is probability of x greater than or equal to 10, which is equal to integral 10 to 15 1 by 15 into dx, which is equal to 1 by 15 into x in the limits of 10 to 15, which is equal to 1 by 15 into 15 minus 10, which is equal to 1 by 15 into 5, which is equal to 1 by 3. So, there is a 33% chance that a man entering the station at a random time during this period will have to wait at least 10 minutes. If x is a uniform variate with the parameter 50 and 100, find the mean, median and standard deviation. Define x as the random variable from uniform distribution. From the given information, we have x follows uniform with parameters 50, 100. Here a is equal to 50 and b is equal to 100. Then for a uniform distribution, mean is equal to median is equal to a plus b by 2, which is equal to 50 plus 100 divided by 2, which is equal to 75. The standard deviation of uniform distribution is given by square root of b minus a whole square divided by 12, which is equal to square root of 100 minus 50 whole square divided by 12, which is equal to 50 divided by square root of 12, which is equal to 14.4337. If x follows uniform distribution in the interval 200, 250, find its probability density function and probability of x greater than or equal to 230. It is given that x follows uniform distribution in the interval 200, 250. Then the PDF of a continuous uniform distribution is f of x is equal to 1 by b minus a in the interval a less than or equal to x less than or equal to b, 0 otherwise. Considering A is equal to 200 and B is equal to 250, we have the PDF as f of x is equal to 1 by 50 in the interval 200 less than or equal to x less than or equal to 250, 0 otherwise. Now, probability of x greater than 230 is equal to integral 230 to 250 f of x dx, which is equal to integral 230 to 250 1 by 50 dx, which is equal to 1 by 50 into x in the limits 230 to 250, which is equal to 1 by 50 into 250 minus 230, which is equal to 20 by 50, which is equal to 0.4. Therefore, probability of x greater than 230 is 0.4. Now, we shall look into certain application of continuous uniform distribution in economics. Pricing. The continuous uniform distribution can be used to model the pricing behavior of firms in a competitive market. In this context, the price charged by each firm is assumed to be uniformly distributed over a certain range, reflecting the idea that firms set their prices independently of each other and without knowledge of the prices charged by other firms. Resource allocation. The continuous uniform distribution can be used to model the distribution of a resource such as land among potential users. This can be useful in determining the most efficient allocation of resources, such as when the government allocates public land to private developers. Income distribution. The continuous uniform distribution can be used to model the distribution of income among a population. In this context, the range of income levels is divided into equal intervals and each interval is assumed to have an equal probability of being chosen. Portfolio optimization. The continuous uniform distribution can be used to model the returns of different assets in a portfolio. This can be useful in optimizing a portfolio to maximize return while minimizing risk. Time series analysis. The continuous uniform distribution can be used to model the behavior of a time series such as stock prices or exchange rates. In this context, the distribution is used to model the noise in the time series, reflecting the idea that the changes in the series are random and unpredictable. Summarization. In this session, we have discussed the concept of continuous uniform distribution. We have defined the probability density function, discussed about the various features such as distribution function, mean, variance, skewness associated with this distribution. Also, by considering practical examples, we have seen how the problems of continuous uniform distribution could be solved. Then, the application of this distribution was discussed in detail. Thank you.